All right, so time for chapter 12. And chapter 12, we're not going to do section 1, so we're going to go ahead and start with section 2. And we're just going to focus in this chapter on volume and surface area of various three-dimensional shapes. So this is something, again, you've done before. I know for sure you do it with Mrs. Pellant. You probably do it a little bit with Mrs. Timney as well. So hopefully we remember some of that stuff, and then that will make this easier. If not, then we're going to relearn it again. All right, so we're starting off with surface area of prisms and cylinders. Okay. So what a prism is a right prism. The definition of specifically we're focusing on right prisms. The definition of a right prism consists of two congruent faces. So those two congruent faces are what we call bases. So the definition of the bases is the two congruent faces of a right prism. Okay, so those are the bases. And so then a right prism consists of two bases, those congruent faces, and then rectangular sides. Those rectangles are not necessarily the same size, so you might have different size rectangles. The only time those rectangles are congruent is if the bases are regular. So if you have a rectangle for your bases, then your sides will not be congruent. If you have a right triangle for your bases, those rectangles will not be the same size. All right, so now surface area, to find the surface area of a solid, it's just the area of all of the faces combined. So it's just the sum of the area of each of the faces. And the faces are the flat surfaces around the shape. So to find the surface area of a right prism, with surface area, really what you're doing is you're just finding the area of all of the faces and adding them all up. So there are some formulas, and we will talk about the formulas, but with a lot of these, you don't necessarily have to know a formula. You just have to be able to break it down into each individual face and find the area of each of those and add them all up. So we'll look at both of those. So you can add up the areas. Now with prisms, what you could do is you could just find the area of one of the bases. That's what this B stands for, the area of the base. Okay, so it says right here, the capital B represents the area of the base. So there's not a set formula for how you find the area of the base because it depends on what shape it is. If your base is a trapezoid, then you have to use the formula for the area of a trapezoid to find the area of your bases that we learned in the last chapter. If it's a triangle, you have to use your formula for the area of a triangle to find the area of the bases. Okay, so the B just stands for a generalized find the area of the bases. However you find the area of that particular shape that is your base. And if you times that by 2, the reason we're timesing it by 2 is because a prism has two bases. So you're taking the area of the top, the area of the bottom, adding them together essentially, which is what happens when you times something by 2. And then you can find the perimeter of the base and times it by the height of the prism. The height of the prism is the distance from one base to the other. All right, so let's go ahead and look at some of those. And again, we'll look at this first example, we'll look at it in the two ways that you can do it, by just breaking down each individual side, and then also by using that formula. Okay, so this first one, we want to find the surface area of a rectangular prism that has a height of 2 centimeters, a length of 5 centimeters, and a width of 6 centimeters. So I'm going to go ahead and just do a rough sketch of that. three-dimensional sketch of this. Hopefully you guys can tell. So it's got a height of 2 centimeters, a length of 5 centimeters, and a width here of 6 centimeters. So that the width is going back into the box. Okay, so there's two options. This first option that we're going to look at is just looking at each of these faces individually. So let me erase this so I can get, so my picture's not in the way. But, so here's what we have. One thing that can help you is to think about unfolding the box. So here I've got an actual image that's a little better than my beautiful artistic sketch. Here's the prism that I sketched. You can see it's a prism because it's got the two bases, the top and the bottom, and then the sides are all rectangles. And then what I'm showing here is just what happens when I try to, if I cut along the sides and I unfolded it. This unfolded view of this prism is what we call a net. Okay, so the net is the unfolded image. And when you unfold a net, you can see really what shapes you're trying to find the area of. So what you can do is when you're looking at this in this particular prism, you can look at it as there's basically 6 rectangles that you have to find the area of. Okay, so thinking about how this would unfold, this is your top, this is your bottom, this would be the left, this would be the right, and then this right here is the front, and this right here is the back. So you can kind of see how those shapes unfolded to create this. So you'll notice in this picture the top and the bottom are the same. Okay, and those are both rectangles that were 5 centimeters by 6 centimeters. So what we can do, I'll go ahead and go to the next slide. And here I've kind of broken it down. I've got the left and the right side, the front and the back, and the top and the bottom. And then their dimensions. So I'll go back to the picture. Here, as you can see, the top and the bottom is 5 by 6. The front and the back is going to be 5 by 2. Just remember it was 2 centimeters high. And it's 5 centimeters this way. And then the left and the right is 2 by 6. So looking at that, you can see the left and the right is 2 by 6. The front and the back are 5 by 2. So those are all rectangles. So think back to the last chapter. How do we find the area of a rectangle? We just take the length times the width. So the left and the right, each of those faces has an area of 6 times 2, which is 12 centimeters squared. The front and the back each have an area of 10 centimeters, or centimeters squared, or 5 times 2. And the top and the bottom each have an area of 30 centimeters squared, or 6 times 5. All right, so now we know the area of each of those individual faces. The only other thing that I want to point out is that the left is 12 centimeters and the right is 12 centimeters. The front is 10 centimeters squared and the back is 10 centimeters squared. The top is 30 centimeters squared and the bottom is 30 centimeters squared. So the surface area of this whole shape would be just those areas all added together, but keeping in mind that there's 2 of each of these. So I took 2 times 12, that's the left side and the right side, plus 2 times 10, that's the front and the back, plus 2 times 30, that's the top and the bottom. We end up with an answer of 120 104 centimeters squared. Okay, that's option number 1. That's just looking at every single face individually and just adding them all up. All right, now the other option is using that formula. 2 times the area of the base plus the perimeter of the base times the height. Okay, so looking at this, I'm going to go back to the picture. Oops. Oops, I gotta get to the right. Okay, sorry. So the area of the base would be the top and the bottom. And so that's 5 times 6, and I multiply it by 2. And then the perimeter of the base was a rectangle. 6, 5, 6, 5. So if I'm finding the perimeter of that, that's 6 plus 5 plus 6 plus 5. And then I times it by the height of the prism. And then 5 times 6 is 30. And 6 plus 5 plus 6 plus 5 is 6 plus 6 is 12. 5 plus 5 is 10, so this whole thing is 22. So you have 2 times 30 plus 22 times 2. And you end up with 104. And so you'll notice that both methods get you that 104 centimeters squared.